Hey everyone. So I want to talk to you for a few minutes about the difference between descriptive statistics and inferential statistics. Now, when we first start talking about statistics, there are so many different terms and categories. Remember, they're not mutually exclusive. So, like we've talked about qualitative versus quantitative, nominal, ordinal, interval, ratio. That is a totally separate characterization than descriptive versus inferential. Okay. So don't think that just because I may say, oh, that's interval data, that means it can't be descriptive or inferential. I know that can be kind of confusing sometimes. Let me share my screen with you. We've got some examples I want to look at to hopefully make this make sense a little more easily. Okay, so just a basic definition of statistics. How about to start off with, even though we've already talked about this? It is simply the branch of mathematics that transforms data into useful information. So, unlike other math classes, statistics isn't just about solving the equation or getting the answer. It's taking our information and putting it into a useful form for decision makers. That's why we're going to spend a lot of time talking about how we display our data. After we get our answers, do we want to put this in a pie chart? Do we want to use words? Do we want to use a line graph? Statistics kind of stands out from the other branches of mathematics. So underneath statistics, we have descriptive statistics and inferential statistics. Descriptive statistics just means collecting, summarizing, and describing your data versus inferential, which takes it a step further. We draw conclusions, we make decisions, we come up with how we would describe a whole group of people based on the information we got from just a small part of that group. And we're going to talk about that more in just a second. But just your basics. So descriptive is just getting the information, collecting it, describing it, summarizing it. And then if we can or we do take it a step further and we use that information to actually draw conclusions, make statements about something. Okay. So let's just talk about an example before we move on. If I say, or you hear, if you watch the news, read magazines, anything, even on social media type platforms, digital platforms, you will see 3 out of 4 dentists recommend Colgate extra whitening. If you ever start to think about what that means, 3 out of 4 dentists, so 75% of all dentists recommend this one certain toothpaste. So do you think the company that published this, in this case, I would assume Colgate, do you think they ask every single dentist in the whole wide world? No. Even every single dentist just in the United States, that would be a tall order. That'd be a lot of people to ask. And you can't force people to respond. So how do they come up with these conclusions? Okay, they are using inferential statistics. And the way they do that is a population versus a sample. So our big circle with all the people in it represents the population. So let's say that big circle represents all the dentists. What I do is I take what I call a sample. I just choose, in this case, 5 dentists from this population, and I ask them which toothpaste they recommend. And if 75% of my sample says they recommend Colgate extra whitening, then I can use inferential statistics to say, well, alrighty then, the whole population, I can assume that 3 out of 4 of them also would recommend Colgate Extra Whitening. So if you're the least little bit skeptical like I am, you're thinking, yeah, is that really right? I mean, can that work? Yes, it can work if everything is done correctly. That is why it is so important when we are doing statistics to make sure that we collect, analyze our information without any bias. What is bias? Bias would be trying to make the results come out the way we want them to. So say I work for Colgate. I'm going to be tempted to try to do everything I can to make sure the most people recommend my toothpaste. So one of the main things we do is we use outside or external sources to come up with this information. People just tend to trust it more. Another thing we do, we have to pick the correct sample. We can't pick the 5 dentists that we personally know. Maybe those 5 don't represent. Or if this is all the dentists in the United States, I can't pick just dentists from the South. That wouldn't be a fair representation. So our sample has to be unbiased. So that can get really, really tricky. But before we get too lost down that rabbit hole about bias, just make sure you understand population is every single person, thing that could fall into that category, and a sample is just a random number. How big your sample needs to be is based on how big your population is, and we'll talk more about those details later. So in descriptive, I would say something like, I had a 90% satisfaction rate when I used all of my customers. When I looked at all of these customers, there was a 90% satisfaction rate. Inferential statistics, I would take a sample, and if my sample had a 90% satisfaction rate, then I would generalize that or draw a conclusion about my population that says 90% of the whole population had a good satisfaction rate. Okay, so descriptive is used to describe, organize, and summarize information about the entire population. Inferential is where I draw conclusions about the population based on a sample. And this really does work, okay, for all my skeptics out there. If it is done correctly, it really does work. I'm not saying that it comes out to be perfect, but if you do it correctly, it comes out to be really close. One thing I like to talk about is the law of large numbers, and we'll get into more detail about this later. But think about if I'm going to flip a coin. A coin has 2 sides, heads and tails. So every time I flip the coin, I've got a 50% chance of getting heads and a 50% chance of getting tails. So if I think about that from a population sample type way, then I would say, okay, if I flip the coin 10 times, according to it being a 50% chance each time, that would mean out of 10 flips, I should get 10 heads and 10 tails. Okay, I don't want this video to be too long, so I won't sit here and flip the coin 10 times, but I guarantee you it wouldn't come out to be 5 heads, 5 tails. But based on the law of large numbers, if I flip that coin 200 times, it'll come out really close. You don't trust me? Just try it. Get your coin, flip it 200 times. 500 times, okay, it ends up working out. So that's why we have to make sure our samples are large enough and there is no bias in our samples. And if we do it correctly, it'll work out. So descriptive, smaller data set, simpler to do, results obtained represent the entire set. There's usually less error. Inferential statistics we normally use when there's a large data set. Because think about it. If I'm just trying to draw conclusions about the freshman students at the Ridgeland campus of Holmes Community College, that's not a huge number. I could possibly ask every single one of them a question. If I'm talking about every college freshman in the United States, that's a whole different story. I can't ask everybody, so I'm probably going to have to use a sample. So if your data set, if your population is small, we can use descriptive statistics, and that's awesome. If our data set is large, our population is large, then we're normally going to have to work with a sample and just draw conclusions about the population based on the sample. So the process is more complex because that whole sampling technique comes in. Results represent a portion, but we use that portion to draw conclusions about the entire population. Therefore, there can be more error involved. So let's look at an example. We measured the heart rate of each student in Mrs. Green's class, the walking class, and the mean was 100 beats per minute. The standard deviation was 2, and the minimum was 50, and the maximum was 200. The numbers don't matter. We measured the heart rate of each student, and here are the results. Inferential statistics. We measured the heart rate of each student in Mrs. Green's walking class, and then we announced that we are 95% confident that the mean heart rate of students who walk regularly is between 200 beats per minute and 50 beats per minute. See the difference there? Under descriptive, we measured each student and we said, hey, here's the results. We can do that because her class is going to be not that many people. Inferential, we measured using a sample, which was Mrs. Green's class, and then we drew conclusions about every student. So even though the wording kind of starts out the same, you got to make sure you read the whole problem so that you can draw your conclusions about which type it might be. So just to re-emphasize, it's not a word, to emphasize again, population, sample. Now look at this. This population is almost all pink dots and a few green dots. If I take a sample from this population, should it be almost all green dots and only a few purple dots, pink dots, whatever you want to say? No, that can't be right. That can't be random, okay? This would be a biased sample, which therefore means all of the data that we do is not going to be correct, okay? We're not going to be able to use it to draw accurate conclusions about the population. So we want to be very, very careful that we don't have any bias. One of the main types of biases we get is wording bias. Think about when somebody asks you a question and they say, don't you agree that statistics is the best class ever? The way that question is worded, don't you agree? It's like they're leading you to agree with them. Okay. So there can be wording bias, the way the question is asked. There can be wording bias in the not the number of questions, but like how the questions are arranged. One method over another method of collecting data could be used to persuade people to actually answer the questions. And so we're not going to get too deep into it right now, but just go ahead and keep into your mind that we have to work really, really hard to not have any bias so that when we draw conclusions about the population, that they're going to be correct. So just a little introduction. I know this can be confusing for some people, and we're going to continue to talk about this. We're just trying to get all those definitions that we can out at the beginning. So when we use these words in problems in the next chapters, we'll already know what they mean. Thanks for watching. Let me know if you have any questions.